not an option here for the STL. Now I could export a 3D model, but again, that's not going to really help me bring it into any other kind of software. Now some of these programs, like MakerBot maybe and Cura as well, likely are starting to support more 3D model file types other than the STLs, like they may accept this OBJ file. But just as a good practice, I would recommend just doing everything in STLs. It's going to be more convenient for you in the end because those files are easier to slice. And also if you're wanting to share them, you don't really want to share an OBJ. You see people doing that all the time, but it's just one extra step for that other person to go and convert that to another file type. So to add the capabilities for exporting STL, we do that through, there is a extension warehouse. So I went into, I did that awful fast, I went into Window, and then Extension Warehouse. And so this is where there's basically a bunch of plugins that you can add onto SketchUp. I'm honestly surprised that they have not added the export to STL extension to SketchUp yet, considering that one, it's the top extension in the extension warehouse, and two, it's developed by SketchUp themselves. So I don't know why they don't just stick it in the program. They do have another program called, I think it's SketchUp Make, and it's much more geared for 3D printing with SketchUp. So that's maybe something you want to look into as well. But since you guys already have this free license for SketchUp, you can do the same stuff through SketchUp. You just have to install this little extension. So I'm going to go and click onto the extension, and then it's going to want one more fun little detail before you can download it, unless they've changed this. Should be nice. White screen is definitely not what I want. Yeah, they're going to make you log into a Google account before you can download that. So just be aware of that. You may want to just create, if you don't already have like an East Schools account with Gmail, you may just want to create a generic Gmail account for your school. This is something that we actually started doing a little while back with all of our new programs, is creating a Google account specifically for your program. And the benefit there being that if you ever move on to another program or something, you have this email address that you can leave behind. It's not your email address. So that way, licensing, warranties, all of that stuff can stay tied to the program. And if you ever leave, they don't have to hunt you down and try to find all of that information. This is telling me that I've got to close SketchUp and then start it again for the plugin to be loaded. Let me save my beautiful house. Okay, so now we can go and go to Export STL, and you can see that's just added now right to the bottom of my menu. We're going to just keep all of the default settings the same here. We're going to export, just going to stick it onto the desktop, save. So now, here we go. This is our STL file, and it looks like on this computer I've got it set up so that STL files are associated with MakerBot desktop. So if I double click that guy, there we go. So the next step, if we were wanting to print our house, would be to take it into some printing software. So when you're writing out a paper that you're going to print out, you go to a piece of software to prepare that paper for printing, right? Go to Word to make that paper. Same thing with a 3D print. when you go to print something, you're going to have a piece of software that you're using to actually send the job to them. It's also going to allow you to prepare the model for printing. So I'm going to take this guy, and all of these things support drag and drop now, so I'm just going to grab my model, drag it into the window, and drop it. And it's already going to start asking me some stuff. So here it's saying scale of the object. The object seems very small. It seems to have been designed in inches. We're going to scale it to millimeters. So it's already saying, hey, it looks like you may have been using inches, and it made this thing super small right now. It should even be millimeters. So it's trying to figure out what's going on as to like why this object is so small. Basically, it's that small because I never set a size in SketchUp as I was modeling. Really, when you were doing this, you would want to know how big you already want the object to be, and you would be scaling everything accordingly. And I think here, it thought we were using inches, but I think we're actually using meters. So really, the object was super large, and it has just interpreted it the wrong way. That's the benefit with 3D models. There were some kids that were picking out 3D models to print, and they were like, well, that one's too big, we can't do that one. You can scale your 3D models to basically as big as small as you want. Now, there's some stuff you got to keep in mind, like if your 3D model has a bunch of really complicated moving parts, like some of the stuff we have back there, when you start scaling those, you're also scaling like tolerances, and you may reduce that past the limit of the machine. So you may have had a cool moving part that you scale down, and now it is a solid part because all of the tolerances got too tight, it can't move anymore. So I'm going to go ahead and just tell it, yeah, let's let it rescale the object. Okay. So there is a relatively large house. Now there's a lot of stuff wrong with this. If I were to just hit print right now, actually let's see what it would do. So like in a program like Word, you have a print preview that's going to allow you to see, it's basically the tool path. It's going to go and look at your 3D model, and it's going to do something called slicing it, where it's looking at each individual layer of that 3D model, and then it's creating the tool path for each layer. So where the head's going to go, when it's going to lift up, when it's going to put down material. So this would be a 12-hour print. We have some ports on, so I imagine it has filled the inside of the house solid for plastic, basically. So yeah, this is the entire house. You can see this area down at the bottom is a build plate that basically just helps with the adhesion to the bed. And if I grab my layers here, I can actually step down through all of the layers, zoom in a little bit more, all of the layers of the 3D model so that you can actually see inside. So there's actually a lot of things wrong with this 3D file. The first thing is technically this is what's called non-manifold. So for a object to be 3D printable or to 3D print well, it needs to be manifold. And what manifold means, like think of like a water balloon. A water balloon is manifold. It is a sealed watertight container. If you take and put a big hole into a water balloon, it's not going to hold that water anymore, and it is now non-manifold. So our house here would be considered non-manifold because there's this doorway going inside. And basically what happened was the MakerBot desktop realized that this was a non-manifold object, and really it shouldn't have been able to print it. A lot of other 3D programs would have thrown an error saying non-manifold. In this case, it made an assumption that we screwed something up, and that it should be manifold, and it's just going to close in this hole. So it went and it closed in this hole, and then it assumed this whole object should be solid, and that's why it was filled up with that support material on the, that infill material on the inside. So really, if I wanted this to actually print, what I would need to do is go back in and actually model thickness to the walls, because right now the walls are one plane thick, and so that doesn't make a lot of sense to the 3D program. It wants the walls to have actual volume to them. So that would take a little bit more modeling to come back in here and to actually add that stuff. So another thing that I'll show you that is something that you have to think about while 3D printing, let's see our beautiful flag, is something called overhang. So the way I explain 3D printing to people is it's basically a computerized hot glue gun in functionality. You've got the hot nozzle, you're taking a material, you're running it through that hot nozzle, it's getting liquidy and laying down one layer at a time. Well, try to think about like if you were to do